This is a plot of Nigeria's national power generation on a Tuesday in August 2026. Within minutes, output crashes from over 3,800 megawatts down to a mere 39. Entire metropolitan areas, including the capital city of Abuja, are thrown into darkness as the interconnected network fails. It is a recurring crisis. Since 2010, the national grid has recorded over 220 partial and total collapses. This latest failure was the third to hit the country in less than a month. These outages force millions of businesses and households to rely on their own expensive polluting alternatives, typically powered by petrol and diesel generators. The national model leaves 200 million people tethered to a single centralized system, where a failure at a single point can take the entire country down with it. But in the state of Abia, the commercial hub of Aba operates differently. This city of roughly 900,000 people relies on its own independent private power system. Aba uses what is known as a ring-fenced grid, a closed loop of generation and distribution that is physically separated from the national infrastructure. Yet, during the same week the national grid went dark, Aba's independent network suffered a total blackout of its own. Comparing how these two systems handle the same crisis provides a direct look at how the architecture of a grid determines who stays in the dark. Architecturally, the two systems are opposites. The national grid's tangled web means a single failure triggers cascading errors nationwide. But Aba's isolated loop allows operators to instantly pinpoint problems, tracing the outage directly to a single failure at the source. This transparency is managed by Professor Naji and his team at Aba Power. As a private operator, they have a direct financial incentive to find and fix problems as fast as possible. Within hours, they identified the specific mechanical culprit. A 50-year-old clutch gear and starter motor had failed at the Oigbo gas plant, cutting off the fuel supply. Because the system is decentralized, the team doesn't have to navigate a national bureaucracy to start a repair. They treat the blackout as a solvable engineering problem. Standard procedure for a national grid failure involves waiting for government funds and navigating layers of political red tape. The private operators at the Oigbo plant, Heirs Energies, took a different approach, launching an immediate, globally sourced logistical rescue mission. They located the specific replacement hardware in the United States and secured it immediately. To avoid commercial shipping delays, the company put the parts on a specially chartered cargo flight that flew directly to Nigeria. The components landed at Murtala Mohammed International Airport in Lagos, where they were pushed through an expedited customs clearance. From there, the critical replacement hardware was rushed overland to the plant to restore gas flow to the turbines. By aligning private financial goals with public needs, a process that could take months under a state utility was compressed into a multi-day logistical sprint. While the repairs in Alva were moving, the centralized national grid remained unstable, leaving millions of citizens without power. The state-owned network continues to grapple with physical decay and a lack of preventative maintenance, making collapses a regular feature of life. But in Aba, within that same week, the new gear was installed and the city's power was fully restored. This reliability has major economic consequences. It allows manufacturing and local businesses to operate without the massive financial drain of forced downtime. Aba's model suggests a different path for energy reliability. Rather than waiting for national reform, cities are finding stability by building localized, ring-fenced networks that operate on their own terms.